So again, I'm playing with it, learning new things every day. Rock on. Okay, here is our warm-up. Olivia's back in her Unit 3 brain, and she's looking for alternating interior angles. She's looking for corresponding angles. And I'm telling her, go back to just lesson 4.1 because these symbols tell me something about this triangle. What does it tell me?
That the two sides are parallel.
Nothing's parallel.
I mean, equal.
Yeah, these angles are going to be congruent because these sides are congruent. That's our isosceles triangle theorem. Sometimes you'll hear it referred to as the base angle theorem. Same. So whether it's the base angle theorem or the isosceles triangle theorem, it has two names. So because these two sides are congruent, I know that these two angles are congruent, which makes this one 25 degrees. How does that help me? What next, James?
Well, because that first triangle has to equal 180.
Mm-hmm.
And 25 plus 25 equals 50. And then subtract that from 180, it's 130.
All right, so he's got some great math there. He's like, add the angles together to get 50, and then subtract that 50 from 180 because this has my triangle sum theorem. Says that the sum of the angles in a triangle is always equal to 180 degrees. So that's putting me at 130. James, you've got a 130 degree angle here. How does that help me find x? Yeah, because x and that 130 degree angle are vertical, which means that they have the same measure. So x is equal to 130 degrees. It's time to classify it by side and angle. What do you want to say? isosceles. I'll buy that because I've got two congruent angles and two congruent sides. But this I'm not sure is acute. Help me out. Yeah. If it's an obtuse angle, it's going to have at least, or it's going to have exactly one angle greater than 90 degrees. Go.
So I'm kind of saying what you're saying. So if one angle is over 90 degrees, it's going to be a obtuse angle. Obtuse triangle.
Yes, it is, because all I need is that one angle. And I want you to think about this one angle taking up more than his fair share. I only have 180 degrees to go around. So if one of them equals 90 degrees, I only have 90 left, and I don't get a triangle out of two 90-degree angles. If one of them is more than 90 degrees, and the other one is 2, I'm never getting a triangle out of that. We need to make sure we have a way for the angles to come together. So once I have one right angle, it's a right triangle. Once I have one obtuse angle, it's an obtuse triangle. For it to be acute, I need to have 3 acute angles. Make sense?
Yes.
All right. So let's talk about this next one. Ask yourself, what do I see? What do I know? What do I need? I see that this angle is 2x minus 5. I see this angle is 2x minus 6. I know that this angle plus these two are going to be 180. But what do I do with this one here? What's he going to help me with? Go ahead, Olivia.
This will help you with finding the angle that's missing.
Go ahead, how?
Because if you minus 180 by 109, you get that angle.
Okay, so 180 minus 109. That sounds like, so 180 minus 110 would be 70, right? So it's going to be 71. You okay with that quick math?
Yes.
So this is 71 degrees here. And then I can set up an equation where this plus this plus this equals 180 degrees. Anybody know another way that fits what we learned? Go ahead, Christian.
Exterior angle theorem. 4x minus 11 equals 109.
Yeah. So Christian's like, hey, wait a minute. That's an exterior angle. So the exterior angle says that that exterior angle is equal to the sum of those two remote interior angle. Now doing this math and getting 71 degrees and adding these up to 180 is going to get you the same answer. The exterior angle theorem helps you get there a little bit faster. So I end up with x having a value of 30. Once I know that x has a value of 30, when I go to figure out what my angle measures are, 2 times 30 minus 6 is equal to 54. 2 times 30 minus 5 is equal to 55. So if I look at a 55 degree, 54 degree, and 71 degree triangle, I know that's going to be a scalene because they're all different. And I know that's going to be an acute triangle because all of my angles are less than 90 degrees.
Because when I'm getting, I put all the inside of the triangle into like an equation equals 180. I simplified it to 4x plus 70.
So 2x minus 5 plus 2x minus 6 plus 71 has to equal 180.
Yeah.
4x minus 11 plus 71 has to equal 180. 4x plus 60 equals 180. 4x is equal to minus 60 from each side, 120. X is equal to 30. Did you find where you went wrong?
Yeah.
Okay. So it doesn't matter how you go about solving it. You're going to get the same answer either way. The exterior angle theorem gives you a shortcut. That's all. Got it? Okay. Next one, I see that I've got parallel lines. So Olivia, here's your parallel lines. My next step is going to be to put those parallel lines to use and say, if I have a 68 degree angle here, how can I justify this one being 68 degrees? Alternating interior angles, I love it. When I need to find this angle, I'm going to go ahead and use my linear pair. 180 minus 92. Sounds like it equals how many? 88. So now if I have an 88 and a 68 degree, then my x is going to be equal to, if I add 68 and 88.
Minus, when you add that up, minus it by 180.
Yes, ma'am. So 16, 15, okay. So I'm going to do my whole adding up. 4 gets me to 160 plus another 20. You okay with it being 24 degrees? So x is equal to 24. Sides and angles, talk to me. Scalene, I heard it. Keep going. It's another scalene, acute triangle. Very good. All right, so we're gonna, oh, go ahead. Yeah, so you could have totally done 92 is equal to x plus 68, absolutely. And that might have been faster, wouldn't have? Yeah. And it's funny because I'm sitting here doing it going, I don't remember doing that math when I did it last time, because last time we used the exterior angle theorem, absolutely. All right, now the warm-up on the back, we're going to get to in a minute. But first, we're going to talk about last night's homework. So would you please take out last night's homework? I want you talking about it with your table group. I'm going to come around and give you credit for your hard work. All right, so come back. Let's go through and talk about this. Classifying the triangle. Yeah. Yeah.
Listen. I just looked at this.
All right, so we want to classify each of those triangles by angle and side. And we need to get used to using the vocabulary as much as we can. Talking about scalene, isosceles, and equilateral. We need to get used to talking about acute, obtuse, and right. So we have a scalene right and an obtuse isosceles triangle. Okay, next one, solve for x. Find the measure of the exterior angle and classify the triangle. So this exterior angle is equal to the sum of the two remote interior angles. I solve for x, and I see I have an acute scalene triangle. This exterior angle is equal to the sum of the two remote interior angles. I solve for x, and then see I have an acute scalene triangle. Now, my version is a little bit different from yours. We had you break it down a little bit to make it a little bit more clear. But if you look at this picture, each of those angle pairs is supplementary. So 1 and 2, 3 and 4, 5 and 6. So when you're asked to find the measures of the sum of angles 1, 2, 3, 4, 5, and 6, that's going to be equal to 3 sets of 180 or 540. You know that the interior angles of a triangle are 180 degrees. So this subtraction problem makes sense to you because we had a total of 540. And when I subtract my interior angles, I get 180 degrees. That means that all of my exterior angles add up to 360. And you're going to figure out when we get to our polygon unit, that's the same always no matter what. So the sum of the exterior angles of squares and trapezoids and rectangles and hexagons and octagons, it's all 360. So we're going to come back and revisit this concept in a couple units from now. All right. When we have an exterior angle, I know that the measure of angle 1 is equal to 4 plus 6. I know that 3 is equal to 2 plus 6. And I know that 5 is equal to 2 plus 4. I know that 2 plus 4 plus 6, which are my interior angles, all equals 180. So all of my exterior angles is going to be equal to 360. It's kind of cool how without any angle measurements, we can see all these facts. All right. So for this one, you were asked to write equations for x and y. I know that x plus y, or 2y plus x is equal to 180. So this green equation comes from this green triangle here. Then I know that this purple equation comes from this y and these two x's. This exterior angle is equal to the sum of the two remote interior angles. So because y is equal to this, I can take this value for this 2x and I can plug it in for that y. That's solving a system of equations. So now that I have everything in terms of x, I can go ahead and solve for that x value. That's kind of a cool problem. You're going to see that again. And it's neat how you have those two isosceles triangles next to each other. Go ahead, Rachel.
How did you get to y equals 2x again?
So this y is an exterior angle with these two remote interior angles. So this y is equal to x plus x because of our exterior angle theorem. Go ahead, Olivia.
So why didn't you combine like terms of 4x plus x? Was that y?
I did. So here I just spelled it out. 2 times 2x plus x. This is 4x plus one more x. That's how I got 5x. I did combine like terms. Keep asking. Anybody else?
So when you got 2x, you got 2x from the.
I got 2x from here. Here are my two equations, green and purple. This green equation comes from this story. X plus y is equal to 180 degrees.
Oh, okay.
And then this story comes from this exterior angle is equal to sum of these two. And I can combine these two equations into one through substitution. And now instead of having x's and y's in both, I can put everything in terms of x. I can solve anything with one unknown. If I have more than one unknown, I got nothing. So if I can combine them and create and put everything in terms of the same variable, then I can use my superpowers of algebra to solve.
Okay.
All right, read these sometimes, always, nevers and see if we agree. Isosceles triangle is sometimes right. Obtuse is never right. Right triangle, never equilateral. Right triangle, sometimes isosceles. Are we okay on that? Give me a thumbs up. Okay. On the back, we have these 4 isosceles triangles. And depending on if I'm given one of the two congruent measures, so here these are two congruent, so 70 plus something has to equal 180. Those are the easier ones. When I'm given just my vertex angle, I know that 1 and 2 have the same measure because they're opposite of the congruent sides. So I'm going to take 30 away from 180, and then I'm going to split the difference to see what's left. Yeah.
There's no way those sides are actually equal.
No, and Nazifa, that is a great point because when we look at the sides in geometry, on purpose, we give you distorted figures to make sure that you're going by the symbols of congruence and not by the eye. So in geometry, don't ever trust your eye. You can't be like, well, it looks right. Mm-mm. If it doesn't have a box in it, it's not right. You can be like, well, they look congruent. You're like, mm-mm. If they don't have the hash marks, they're not. So you are exactly right. Those are definitely distorted triangles on purpose. Same with this one, especially.
Yeah.
This one is really off. So we have to trust our symbols. That's a great point. Thanks for sharing. Go ahead.
With the angles, will we ever get like a decimal for one of the angles?
You know what? Sometimes yes, sometimes no. The math is not always guaranteed to be pretty. So you get what you get. But I got to be honest with you. In geometry, we work on making a lot of things work out nicely. So if you ever do get a fraction or a decimal, I know that when I'm doing the work, I go back and do it again to look for my mistake. Because if I do get a decimal or a fraction, a lot of times I go back and just double check it because it's usually designed to work out a little bit more evenly. So, any questions on number 6, A, B, C, or D? I like those problems. They're good ones. All right. These problems are my favorite. Go ahead, Abdul.
Can you go over D?
D? Sure. So, because these two are congruent, I know these two are congruent. So the sum of these two is 50, right? Which means this one has to be 130. So there's two types of people out there, people who think number 7 is fun and people who wish number 7 was fun. I love having that little daisy chain of angles take me across the page. I think that's cool and fun. What's better is when we pull in some parallel lines and we can start doing some alternating interior and exterior angles. That kind of steps it up one level. Any questions on any of those that you couldn't figure out? Go ahead.
So if there's a right angle,
Yes.
would the angle under, like, would that be just like a, wait, never mind, my question don't make sense.
These are always going to be vertical. Let me answer you because it actually does make sense. If you see intersecting lines and you see one right angle, you've got 4. So as soon as you see one, that means that those lines are perpendicular. If those lines are perpendicular, then they intersect at a right angle and everything is 90 degrees. The linear pairs are congruent, 90-90. The vertical angles are congruent, 90-90. So once you see one box, you see 4.
How do you get every other angle? Wait, never mind, because if you did 90 plus 30, then.
Yep, there you
So
go.
just one, if you just find one, you'll find the rest.
That's it. Takes you across the whole figure. Kind of cool. All right, next up, ABC is isosceles. When you're naming the base, your base is going to be this side here. That's not one of the two congruent sides. And our legs are AB and AC. And because they're equal to each other, I can solve for X.
So.
And I said it was acute. There's no guarantees. Without angle measurements, I can't guarantee acute. It looks acute, but Nazifa and I are like, don't go by the picture. Yeah. Okay. Anybody else? Question? Okay, right inside the equation to find the value of X. So my exterior angle is equal to the sum of my two remote interior angles.
How'd you find, for, write and solve equation, how'd you get
These, well, here's where I wrote and solved the equation and solved for X, and then I put that value of X in for BC, AB, and AC. That's how I found these measurements. Down here, I did the same thing, solving for N. This angle is equal to the sum of the two remote interior angles. When I solve for N. Sound okay? What else you got? Go, James.
I did number 9 a different way. I first, well, I knew that the angle, like, it's not
Well, what you probably did was you said that this angle can be supplementary, but you can't get these two without getting this one. Like once I know this is 112, I know that this plus this is equal to, plus this equals 180, but I need to use this one to get it. You could have said that this angle is equal to 180 minus 4n plus 12, and then take this answer plus this to equal 180. Yeah, that's a lot of work. Did you get the right answer?
Yeah.
Go ahead.
How'd you get obtuse?
Because I got a 112 degree angle.
I thought the 68 was inside.
No, that's my exterior angle. See it now? All right, so here's what I want you to do. I want you to go back to the back of your warm-up. And with your group mates, I want you to go ahead through, talk about each of these, and tell me what you think. On your mark set, talk. All right, so let's take a look at this warm-up. List the angles of M and P in order from smallest to largest. Okay, so if I need to find angle N first. So did you add 80 and 63 and get 143? And then did you count up to 180? I need 7 here to get me up to 150, and then another 30. You guys okay with that math? So 37 degrees. So I know right away that my smallest is angle N. I know that my next smallest is angle M. And I know that my next smallest is angle P. By the way, there's 2 ways of listing these. I could say that the measure of angle N is less than the measure of angle M, which is less than the measure of angle P. Pay attention here. This is where I'm talking about numerical values, and this is where I'm talking about actual things. Do you see the difference between whether I'm talking about the angles or their measures? Okay. Keeping in mind also, remember that the alligator eats the larger one. So remember our conversations in algebra about that alligator that eats the larger one. Did your teachers ever talk to you about that? Please say yes.
Yes.
Okay. The alligator eats the larger value. Yes.
That's a very nice alligator.
Well, thank you. You did not know it was an art slash math class. You're very funny. It looks like he lost a couple teeth though. There we go. Get them all the way down. All right, so I need to list the sides of JKL in order from least to greatest. So I come down here and I know that the distance from L to J is smaller than the distance from J to K, which is smaller than the distance from L to K.
So we have to write like that, because I wrote it like LJK.
You have a choice. You can talk about line segment LJ. You can talk about line segment JK. You can talk about line segment LK. These are my numbers, my numerical values, which is why I can use my inequality signs. And these are my segments. So if it says list the sides, this is actually the better answer, but I'll accept the other. What I won't accept is these symbols in between these things. So you have to make a decision. Are you listing the things in order from least to greatest? These are the angles, these are the segments. Or are you listing their measures as an inequality? These numbers and these numbers. Are you with me on that? So it says now list the sides of triangle MNP. And I'm like, yeah, I don't know anything about the sides of MNP. Because here's the deal. If I drew a triangle the same exact shape as MNP, but smaller, it would have all the same angle measures. So I don't know what their side lengths are. So I'm gonna skip it. Go on to number 5. Now list the angles of J. Yeah. Nobody. How am I supposed to know what the angles are? Huh. All right, skip it. When I have triangle MNP, okay. Oh, good. They tell me now. MP is 5. So I can fill that in. Thank you. And NP is 8. Thank you. I can fill that in. What are the possible lengths of triangle MN? I don't know. I don't know. I need some math. So I'm going to go get some math. Take a look at the notes I just passed out to you. Notes 4-2. Do me a favor and to yourself read our first theorem of the day. Angle side relationship theorems. They go like this. If one side of a triangle is longer than another side, then the measure of the angle opposite the longer side is greater. Ah. If the measure of one angle of a triangle is larger than the other angle, then the side opposite the larger angle is longer. Hey, that's kind of cool. Then it tells me to take note of vertex and not side length names. So here's how we name triangles. Are you ready? Here's vertex C in a capital letter C. Vertex C is always going to be opposite of side C with a little c. See vertex B over here, capital letter B. He is always going to be the angle opposite of side B.
What do you mean by angle opposite?
See how this angle? is opposite.
Like, how would we measure what the opposite is?
We just need to know it positionally.
Oh, okay.
So if you see there, you and Sydney are sitting opposite of each other in your table group, right? So across from, opposite. So if I have little letter A and capital letter A, they are opposites. So when we like to name things, triangles and sides, it helps us to call them by the same letters. And basically what this says is the larger side is opposite the larger angle. The larger angle is opposite the larger side. Same with the small and the mediums. Okay, so when we look here, I see that angle C is opposite this side length of 3. And I see that angle A is opposite of this side length of 5. Because 5 is greater than 3, I know that the measure of angle A is going to be greater than the measure of angle C.
Oh.
You with me now?
Yeah.
All right, let's talk about this 40-degree angle is opposite of DF. This 60-degree angle is opposite of EF. So I know that the distance from E to F is bigger than the distance from D to F because of the size of that angle. Go ahead.
Would D to E be bigger than F to E?
Well, in this circumstance, yeah, because if this is 100, that means that this is an 80. So then that means that D to E is going to be my biggest distance. Absolutely, Ethan. All right, so back to the warm-up. List the sides of triangle MNP in order from shortest to longest. I know that the distance from M to P has to be the smallest because it's opposite of the smallest angle. My next smallest angle is angle M, so the distance from N to P is going to be next biggest. And then my longest segment of the 3 is going to be the distance from M to N. For this one, if I have to list the angles of JKL in order from smallest to largest, all I got to do is look at my side length values. And I know that angle K is going to be my smallest. I know that angle L is next. And I know that angle J is my largest. If I want to talk about and compare their measures and use these symbols, I need to make sure I'm talking about the measures of the angles. Go ahead.
So K is opposite to LJ and L is opposite to JK.
Mm-hmm. Go ahead. All right, so then we come down to this next conversation. And we want to try to see what's going on here. So it says in triangle MNP, the distance from M to P is 5. Got it. The distance from N to P is 8. What are the possible lengths of MN? I wonder if there's another rule that we have to learn. And here it is. So before we get to that, the corollary of our triangle exterior angle theorem, and I want to make sure you understand when we're talking about a corollary, whether it's an addendum, that was Maggie's word, I think, and oh yeah, while we're here, let's talk about this, or Mr. Logan says his class calls it follows that, or it makes sense that because. So this one's an interesting one. Because I know that the measure of angle 1 is equal to the measure of angle A plus the measure of angle B. Keep in mind 1 is an exterior angle. So it's going to be equal to these two angles added together. Then that means that 1 has to be bigger than A and 1 has to be bigger than B. If 1 is equal to the sum of A and B, 1 has to be bigger than each one individually. That just makes sense. That's just logic. Because those angles can't have a measure of 0. All right, here we go on to the triangle inequality. So this one's kind of cool. This one says the sum of the lengths of any two sides of a triangle has to be greater than the third side. So think about that for a moment. Being able to draw these three inequalities over here. Because this is true for all three sides of the triangle. So that means that this side plus this side has to be bigger than this side. That's what this first one says. But that also means that these two sides together have to be bigger than B. And that also means that these two sides added together have to be bigger than A. So we can write three different inequalities from that triangle. Go ahead, Maggie.
Can this theorem be used to prove that a thing is a triangle?
Yeah, absolutely. All right, so we'll go ahead through and we'll talk about these side lengths. If I want to know something in algebra, I stick an X on it. So according to this theorem, that means that the lengths of any two sides have to be bigger than the third side. The lengths of any two sides have to be bigger than the third side. The lengths of any two sides have to be bigger than the third side. I don't know where this side falls in, so I know it's got to be a part of these inequalities. Now, when I write these inequalities, let me ask you, which one of these inequalities makes no sense? Yeah, because isn't 8 already bigger than 5? So we can typically cross one of these out. This means that X has to be smaller than 13. When I add these two together, X has to be smaller than 13. When I solve for this inequality, X has to be bigger than 3. X has to be greater than 3. So these are my possible side lengths for X. But here's the interesting conversation. Come back here. I know that X has to be my biggest side in this triangle. So for this triangle, with those angle measurements, I know X has to be bigger than 8. So X has to be bigger than 8, which is bigger than 13. So in order to make a triangle, he can be any of these lengths. But once I'm given these angle measurements, I know that X is opposite my largest side, so I know he has to be something greater than 8. All right. Sound okay? All right. Flip over. Let's do some practice. Write the measure of the sides and the angles in order from least to greatest. Explain how this graphic supports the triangle inequality theorem. And take a look at 3 and 4 with your table groups. Go ahead. Jump in on your mark, set, think. Go. All right, so for number 1, write the measure of the sides and angles in the triangle in order from least to greatest. We'll do sides first. Well, we should do angles first because that's what's given here in A. So I know that the measure of angle Z is smaller than the measure of angle X, which is smaller than the measure of angle Y. So because of that, I know that my smallest side is the distance from X to Y is smaller than the distance from Y to Z, which is smaller than the distance from X to Z. So if they ask you for the measure, that is the better answer. So for this one, I know that the distance from B to C is smaller than the distance from A to C, which is smaller than the distance from A to B. And because that's true, I know that the measure of angle A is my smallest. Then comes the measure of angle C. And finally, the measure of angle B is going to be the biggest. All right, so this conversation here supports the triangle inequality theorem because it knows that the sum of x plus y has to be greater than z, which is that third side. And as x plus y gets smaller, as this value x plus y gets smaller and smaller, your triangle gets, it's interesting to see what happens. It gets more obtuse, which is what's happening here to this angle. And it kind of goes to the point of very close to a straight line, right? And then we know that at a straight angle, we're going to end up with no more triangle, right? As that goes closer and closer to being straight, it stops being a triangle.
Okay, so for the A, for the X, Y, Z triangle, how do you figure out the lines again? Like,
So I know that A for the XYZ triangle, this is my smallest angle. So that side opposite is going to be my smallest distance between those points. Go ahead, Olivia.
I wrote it, YX, YZ, XZ. Is that okay or not?
So if you wrote it as segments, it's got to be a segment XY, comma, segment YZ, comma, segment XZ. Truth is though, because this asks you about the measures, the better answer is to keep it in numerical values. Any other questions? All right. So a triangle has one side of 12. So just draw any shaped triangle. It doesn't matter what it looks like. Give yourself a side of 12 and 20 and x. Because what we want to do is come up with 3 inequalities that describe the possible measures and the values that x could be. And I know that I'm looking for x to be greater than some minimum value and x to be bigger than some maximum value. And the interesting thing is, by making x super small or super big, that's going to be what ends up creating that straight line, that straight angle, which we can't have, which is why these are not equal to. They're only, x has to be bigger than this value and smaller than that value. So I want you to think about 3 inequalities that you can write, and one of them is not going to make any sense. So when we talk about the sum of the 2 measures of the sides has to be bigger than that third side. So when you fill in each of your values, you're going to take time to have each of these three sides, 20, 12, and x, by itself on one side of the inequality sign. Maybe that makes more sense to you. So I know that x plus 12 has to be bigger than 20. I know that x plus 20 has to be bigger than 12. And I know 12 plus 20 has to be bigger than x. Which of those three inequalities makes no sense? Which of those three inequalities can we cross off? Which one, Christian?
The middle one.
Yeah, that middle one, because isn't 20 already bigger than 12? So because of that, I don't need to worry. Because of that, I can say, okay, well, this one's a given, not a problem. So when I solve for x here, 20 minus 12 is 8. I know x has to be bigger than 8. 20 plus 12 is 32. So I know x has to be smaller than 32. So those are the range of values that x could be equal to. All right. Number 4, you turn to your classmates, and I want you working on that together. Go. All right, so if I draw my triangular playground, one side is 100, the other side is 200, and then I've got my third side. Telling ourselves inside our head that the sum of the two sides of a triangle has to be bigger than the third side. So x plus 100 has to be bigger than 200. X plus 200 has to be bigger than 100. And then 100 plus 200 has to be bigger than x. Which of these three makes no sense? Yeah, that middle one. So it ends up being the middle one because that's how I end up writing it. But don't always assume it's the middle one. Don't do that inductive reasoning. You're like, oh, she crosses off the middle one every time. No, I cross off the one where my greater value is already bigger. All right, subtract 100 from each side, and I get x has to be bigger than 100. So 100 goes here because x is bigger than 100. Add 100 and 200 together, and I get 300 here because then x has to be smaller than 300, and that's what that says there. All right, we got one more to go. There is a typo here. Make sure it's xz because I have a value for xy of 11. So I know that 11 plus 6 has to be bigger than x. I know that x plus 6 has to be bigger than 11, and x plus 11 has to be bigger than 6. Which one do I cross off? Yeah. I tried to do it differently that time. So that means that 17 has to be bigger than x, and x has to be bigger than 11 minus 6 is 5. So this distance here from x to z has to be smaller than 17 and bigger than 5. Take a look at these 1, 2, 3 problems and see if you can find a shortcut. Talk to your group mates about a shortcut to finding those values. Let me know what you think. Yeah, so 2 things to add. If I'm looking at these values, when I add them, I get my upper limit. If I subtract them, I get my lower limit. So adding them gives me my upper limit. Subtracting them gives me my lower limit. Nazifa earns you guys a Smarty because the question says, what is the maximum total length of fence you could possibly need? So that is what we're looking for, not necessarily the minimum. And then here, adding the numbers puts it here, and subtracting the numbers puts it there. When I make you think about the equations first and solve them, hopefully that drives in the concept. When we find a pattern and do that inductive reasoning, making you conjecture, hey, can I just add and subtract them? Yes, you can. If you forget about that shortcut, go back to your conceptual understanding of, oh, in a triangle, the sum of any two sides has to be bigger than that third side. All right, here's a vocabulary word for you, composite figures. Composite figures is when we put things together. And when we talk about listing the sides from longest to shortest, this side here, BC, is an interesting conversation because BC is repeated in both triangle ABC and triangle BCD. He happens to be the longest of one triangle and the shortest side of another triangle. So what we have to talk about is each of the two triangles separately. If this is 90 and this is 30, what's this angle measure here? 60. So the side opposite my 30-degree angle is going to be my shortest. It says list the sides, so we'll follow the rules. Then comes my side opposite my 60-degree angle, and then my side opposite my right angle. This is the sides of triangle ABC. But guess what? It's a composite figure, so I'm going to keep going. So we got some figuring out to do. Since these lines are parallel, these angles are going to be supplementary. Since this is perpendicular, so will this one. So what's this angle measure here? 60. If this is 60 and this is 50, what's missing here? 70 degrees. BC is opposite my 50-degree angle. He is my smallest. CD is opposite my 60-degree angle. He's next. BD is opposite my 70-degree angle. He's last. These angles are for triangle BCD. Notice I only have to list BC once, even though he's covered by both scenarios. He's like that link between the two sides.
This will all be on the test. Next class.
All right, the measures of three sides of a triangle are given. Use a triangle inequality to find all values of x. Make sure you go ahead and draw a triangle. And give yourself 2x plus 5 on one, 4x on the other, and 30 minus x. And set up your three inequalities. I know that 2x plus 5 plus 4x has to be greater than 30 minus x. That's this side and this side has to be bigger than this side. I'm going to just go around the triangle. 4x plus 30 minus x has to be bigger than 2x plus 5. That's this plus this has to be bigger than this. And for number 3, I'm going to come up here where I have more room. I know that 30 minus x plus 2x plus 5 has to be greater than 4x. So each of those scenarios, I need to combine like terms and simplify. I'll give you a minute to do that. Go ahead. So I'll go ahead and write my values here. X has to be smaller than 35 divided by 3. And X has to be bigger than 25 divided by 7. They're not the prettiest numbers, but they're still numbers. All right, so here's what you need. You've got about 5 minutes left, and I want to make sure that you know what's happening next class. So you have a quiz next class, and the quiz is guaranteed to be short. Yeah, but that doesn't mean it's going to be easy. So we don't want a lot of time because we have some important lessons on right triangles to cover. So we want you prepared. With practice comes speed and accuracy. The more you practice, the better you are at doing anything. On the top of the note sheet I handed out to you that I just passed out, would you please write the word math space, because you also have a math space practice. So you have math space, 10 questions on that to help you get ready for the quiz. And these questions, some of them are very fast. Some of them require more thought. Here's what's on the quiz. Can you classify a triangle by sides and angles? Can you solve isosceles and equilateral triangle problems like you did in the homework? Can you tell me what the missing angles of a triangle are? Using the triangle sum theorem. Can you solve for exterior angles? And can you tell me the ranges of shortest to longest? And those ranges in terms of missing side lengths, yes. Yeah. All right. So you have, I don't know, 4 minutes. If I took your paper away from you 4 minutes early, would you be upset?
Yes.
So get busy.